In this video, we'll review the calculations for the Hydrate lab. Our crystals have copper ions and sulfate ions, and because they're in a 1-to-1 ratio, we would write it as CuSO4. Because of the +2 charge on the copper ion, we would name this as copper-2 sulfate. But note that there's also water molecules integrated into the crystal structure. We'll let those little circles represent the water molecules. Because of the water contained in the crystal, we refer to this copper sulfate as a hydrate. We show this in the formula by putting a dot next to the CuSO4, and then we write the water molecule. But we also leave a space for an N. The N stands for the molar ratio. That molar ratio in this case gives us the number of moles of water compared to the number of moles of copper sulfate. If we pretend that each particle in the diagram represents 1 mole, and you do a little counting, you'll find that there are 18 moles of water for 6 moles of copper sulfate. If we reduce the 18 moles divided by 6 moles, we get 3/1. And that 3 is our N. And we'll name the compound, therefore, with a tri, so it's now called copper-2 sulfate trihydrate. As part of the lab, we're going to find out what N is for the real copper sulfate crystals. In order to do this, we'll take our hydrated copper sulfate crystal and we'll separate out the water so that we can take the mass of that. But what's left behind is what we call an anhydrous crystal, which is without the water. So we'll call this the anhydrous copper sulfate. And of course, what we have left also is the water. Here's some sample data. We start with 5 grams of the copper sulfate hydrate. We heat it up, and we find that we end up with, at the end, 1.80 grams of water and 3.20 grams of the anhydrous copper sulfate. Notice that the two numbers add up to the original 5. In the lab, we aim to describe the amount of water contained in the crystal in 2 different ways. One is to find the percentage of water by mass of the entire hydrate. The second will be to find the molar ratio, N, of the water to the anhydrous copper sulfate. First, to find the percentage of water by mass. Now remember that percentage is given by a part divided by a whole and then multiplied by 100. In this case, the part is the water that was released and the whole was the original hydrated crystal. So we'll divide the mass of the water by the mass of the copper sulfate hydrate. Using our data, that means 1.80 grams of water divided by the original 5 grams of copper sulfate hydrate. Running the numbers, that gives us 36%. So that means that 36% of the mass of our original hydrated crystals was actually made up of water. Now we'll describe the amount of water in the hydrated crystal by finding N, the number of water molecules per each copper sulfate unit. This will allow us to write the proper formula. As discussed earlier, that involves dividing the number of moles of water by the number of moles of the anhydrous copper sulfate. Here's what the calculation looks like. First, you'll have to convert the number of grams of water to moles of water and number of grams of copper sulfate to number of moles of copper sulfate. When you do this, you'll see that you'll have to reduce your fraction so that you'll have an integer value for N. In this case, we get 5, and that allows us to name the compound as copper-2 sulfate pentahydrate. And now you should be ready to try the practice problems. Good luck.